Okay, so we're going to take a look at functional reactive programming in Whiley, or FRP as it's called. So FRP is something that's been popularized by systems like React and Angular, and also by programming languages like Elm, which is pretty cool. So we're going to be using a programming language called Whiley, which is quite an unusual language, but really the things we're going to look at apply generally. Cool, let's do it. So what we're going to do is we're just going to look at how to build a really simple FRP application in Whiley. And this is the application. We can see we've just got two buttons, the plus button and the minus button, and a little counter in between. And if we go plus, the counter goes up. And if we go minus, the counter goes down. And that's it. So our little web application is pretty straightforward. If we know how the DOM works, effectively what we've got at the top is we'll have the window, which is the DOM object representing the enclosing window. Below that we'll have the document, which represents everything inside the page. And then some way below that, we'll find the actual buttons and the controls of our application. In this case, we've just got a top level div, and then we've got two buttons underneath. It's the left button, then there's a label, and then there's the right button. Like so. And that's all there is to it. Right, so functional reactive programming. What's it all about? So this is just a little recap of the basic ideas. I'm not going to go into all of the details, but just to give a rough overview. So essentially what we have is we have states and we have transitions between states. So here we have a few states and just some simple transitions that are just moving us between different states. Now the actual content of the states, well, that would depend on exactly what the web application you had was doing. In the case of our simple counter application, then the state is simply the integer value itself. So in this case it might be 0, then we could press the plus button and then it would go to 1, and then it would go to 2, and maybe we press the subtract button and we get a fourth state and we go down, back down to 1. Underneath the model we then have the view layer. So let's say this is the model layer, and then underneath we have the view layer. So this is where the virtual DOM lives. And what we're doing is we're translating our state into this abstract representation of a web page, which we're calling the virtual DOM. And in this case, it's pretty straightforward. So we just have a top level div, and then we're going to have a left button, which is my plus button. We're going to have a text label in the middle, which for this state would be just 0. And then we'd have the subtract button on the right hand side, like so. And we're just mapping that state into my virtual DOM representation, just using a simple function that takes a state and returns a virtual DOM node. It's very straightforward. So for different states, we're going to get slightly different trees. So for the second state, we'll get essentially the same. Right, we've got the plus node. This time the label is going to be different because it's going to be 1 and not 0. And up here, we've got the subtract button as before. And what we can see, if we compare the two trees, is that this node here has changed from the original tree, and likewise the parent node has changed as well, by definition. Otherwise, the tree remains exactly the same. Now in this case, there are only 4 nodes. It's pretty straightforward, but we could imagine there being many nodes, hundreds of nodes even, that are completely unchanged. So underneath the view layer, we have the actual DOM itself, the actual rendering on the web page. So here's a little example rendering, and I've got another one over here. Those are just 2 example renderings of my little web application. And all that's going to happen is the the rendering will convert from the virtual DOM into the actual DOM. And that last stage is handled automatically, in my case, by the framework that we're using, the FRP framework that we're using. So in terms of, as a programmer, what we need to do, well, we need to define the model. We need to define the different kinds of transitions. So for example, what happens when the plus button is clicked, or what happens when the minus button is clicked. We also need to provide the translation from the state into the virtual DOM, but then everything else is taken care of for us. So working out what has changed between two trees and then updating the DOM as efficiently as possible is all handled by the framework. Right, so finally we're going to build this FRP application that just counts numbers up and down. So I've just created a little demo directory, as you can see. Inside the directory we've just got 3 files. We've got the index.html file that's just going to drive the web application. We've got the Whiley file that contains all the source code of the application. And we've got this other file, which is the y.toml file. And that's the build configuration file. Right, so let's have a look at this build configuration file, the y.toml file. What have we got inside it? Well, just a few fairly straightforward things just to define the name of the package and the version. We don't really need those things, but it's nice to have them. We've also got the JavaScript platform we've specified, and that just means we're going to build JavaScript as opposed to just building the Whiley intermediate language. And we've also got some dependencies down here, and you can see the dependency that I've listed is the web framework. And this is the FRP framework that we're going to be using today, and you can see I've given it a version. So let's have a look at the index.html file. What have we got inside here? Well, we can see that I'm bringing in a large number of JavaScript files. We've got the Whiley standard library, we've got the JavaScript core library, we've got our DOM binding, we've got the FRP web framework that we're using, and we've got the main application on top. The application itself is very straightforward. It simply calls the run method, passing in the window so that it has access to creating DOM elements and so on and so forth. Now let's have a look at the Whiley code. So this is the complete application that we've got at the moment. It's not finished yet, and it doesn't do everything that we want it to do. But we can see the start of what's happening. Firstly, I've imported my DOM binding. I've also made a few aliases here, and the aliases are basically just convenience. So what I'm doing is I'm naming a node to be a node parameterized with my state from the web framework, and likewise an action that we'll see later is being renamed from an action parameterized with the state that's in the web framework. And here we've got my state, and at the moment my state is just a simple counter, and that's it. And then we've got my view transformation, and this is just a pure function, takes in a state and returns a virtual DOM node. At the moment all it does is it just returns hello world. It doesn't do anything particularly interesting. And we've got a little bit of boilerplate code down the bottom which essentially sets up the web application to run. In particular, we access the div that we want to put the web application on. We initialize the model. In this case, I set the counter to be 0. And then we create the web app and we run it. So let's have a look at this. First thing we'll do is build the application. So here we're using the Y tool to build the program, and that will use the y.toml configuration file to determine what to do. So now that it's finished, you'll see that it's generated a whole bunch of new files. In particular, we've got all the JavaScript files that we've generated, and we've also got some Whiley specific files that are just essentially intermediate files. So we can run the application. So let's do that. So I'm just going to go and open the file. So let's find it here in the demo directory, open the index.html file, and there we have it. Very straightforward. Okay, so now what we want to do is update the application so that it actually does, roughly speaking, what we want. So the key thing we want to do is we want to start by having a more interesting view transformation, and we want to add in the 2 buttons, and we want to add in the text label. So let's do that. So we're going to want a button. So let's call that increment button, and we're going to have button, which is the decrement button. Just give it the minus, and we're going to want a string label as well. So let's have a look. In fact, that's not quite right, is it? There we go. That makes more sense. I'll call that the label, maybe just lab for short. And we're going to just create that by converting the counter into an ASCII string, like so. And then we can just wrap the whole thing up in a div at the end. And we'll put the increment button first, then the label, then the decrement button, like so. Now to make this work, we're going to need a few imports. So in particular, I'm going to want to import, let's see, the button from web HTML and the div as well. So let's put both of them in there. That should be okay. And we're going to need to import the standard ASCII library so that we can convert into an ASCII string, like so. And we're also going to want to import the JavaScript native string from the JS core library, like so. Let's have a look at what happens if we try and build it. Okay, so what we need to do is we need to actually cast this into a JavaScript string, not an ASCII string. So let's try that. Okay, and oh, I see the problem. It's actually expecting an array of nodes, and I've just tried to put them in one by one. Okay, and now it's finished. Let's just have a look at how the application looks. And here we go. So now we have 2 buttons and a label. But at the moment, the buttons don't actually do anything because we haven't connected them up. So if we look at our application, we're generating our virtual DOM from the state. It's quite easy. And we've got our buttons, but we need some way to connect the buttons back to the model. And so the first thing I'm going to do is I'm going to create some transitions basically in my model. Right, so the increment transition. So all it's going to do is increment the counter. And we can do a decrement transition as well. Like so. It's accepting a mouse event here because that's what the button's going to generate. And we're returning a state plus a bunch of IO actions. And I need to incorporate the mouse event from up here. And let's just put that in. So that's going to be an attribute. And it's going to be the click attribute. And I'm going to pass in increment in that case, like so. All right, and we'll do the same down here, except we're going to connect it to the decrement function, and I'm going to need to pull in the click attribute as well. So let's do that. So let's see what happens if we try and build it. Okay, we've got a problem. Okay, I've left out the name of that return value. So let's just give it a name. A is for actions. Oh, and I've spelled deck wrong as well. There we go. All right, so let's have a look. Reload it. And now it's working. Pretty straightforward, eh? Okay, so now what I want to do is show a more interesting application, something that makes a network request, shows us how to use I/O and how to break out of the functional space and use side effects, that we would normally expect in our web applications. Okay. So the application that we're going to look at now is a little bit more complicated. It's actually a running application, and you can see it at whileylabs.com. And all the application does is just provide a way for us to type in Whiley code and compile it. So here I've got a really simple implementation of the absolute function, and I've got verification enabled, and I just click the compile button, and that's going to send an HTTP request over the wire to the server that's running on AWS, and then return the response. And so the actual compilation happens on the server, not on the client. Okay, so let's maybe try and break my example to see what happens. Let's go like this, return X. So instead of returning a natural number as the post condition requires, we're returning an arbitrary integer. And we can see the verifier has found a problem. So this application is implemented just in native JavaScript. It accesses the DOM directly. It doesn't use FRP. And what I want to do is actually recreate it in an FRP style. Okay, so let's just go ahead and have a think about how this more complicated application works in terms of making a network request to compile code. So again, as before, we have a bunch of states and those transitions between the states. So here's some simple states. So those states, the transitions could be things like toggling the various options on the screen. They could also be pressing the compile button and asking the compiler to compile the Whiley code. So the key challenge is that we're operating at the model layer, we're operating in a functional space. And that means we can't have side effects. And so it is pure. And this is one of the key advantages of using functional reactive programming. In particular, it helps us to debug our application, to debug the model, because we know that it's pure, there are no side effects and so on. But it also means, well, it's more challenging if we actually want to have side effects. And of course we do. So let's imagine we wanted to make an HTTP GET request at this last point. What would happen? Well, of course we've got our machine, and our machine is what's actually going to make the request up here. And we've got some server. That's what we're actually going to be making the request to, like so. But the question is, how do we get from the functional model into this impure space at the top? Well, the key is we have to actually break out of the model, the functional model. And we do that by using an action. And so we request an IO action that's going to perform the GET request for us, and we provide a callback. And that callback will then bring us back into the model with a response of some kind. And so we're basically breaking out of the pure space into the impure space. Then the system is performing the GET request on our behalf, and then returning us back into the pure space with the result. And here we have the actual application running using the web.y FRP framework. And I've used the max function to illustrate this time, and it's got a slight bug in it. It should be returning X and not Y. So if we compile this, we can see that the tool is finding the error, and we've actually got a server that's running on the local host in the background. And so we're talking from the FRP application over the network, even though it's not actually going off the machine, using HTTP. So there are a bunch of challenges that writing this FRP application faces. Firstly, we've obviously got to be able to make the HTTP post request in order to send the code to the server and retrieve the response. Secondly, we've also got to interact with the ACE editor, and that is the editor that we're using here to perform syntax highlighting. Now this is a challenge because the ACE editor is a native JavaScript. It's not written in a functional style, it's not written in Whiley, it's completely foreign. We can't access it directly from our model because it's not functional. And so we're going to have to use an IO action again to call out and actually execute some standard interaction with the DOM in order to actually get the information that we need out of the editor. Okay, and here we are. And we can see there's quite a lot more going on, and I'm not going to show you everything because that would just take too long, but we'll have a look at the main things. So if we move down, we can see the state here, and there's a bunch of stuff going on there. Firstly, we've got an actual state variable, so this is, we can think of it kind of like a state machine, and we've got different states that the web application can be in. So we might be ready, which basically means we're waiting for someone to press the compile button. We might be ready to run, which means we're waiting for someone to press the compile button, or we've previously compiled some code and we actually want to try and run that in the browser. We might be actually compiling code, in the process of waiting for a GET request to come from the server, and then we'll be processing a response back. So it could be a successful response, and we've printed, we've shown the little green box saying it's successful, or it could be an error response indicating a failure, and so on and so forth. And then once we've sort of finished, processing the success state, once the little green box is finished and goes away, then we'll just go back to either the ready or the ready run state. And so looking in the state itself, we've got the state variable, which tells us which state we're in. We've got the output. This is the output to the console. We've got the binary. This is actually the JavaScript that's been generated. And so when we want to look at the JavaScript kind of window, then we'll see what's in that string. And then we've got some booleans for each of the flags. Boolean to indicate the verification is enabled, Boolean to indicate whether or not the console is being shown, and so on and so on. We've also got some identifiers at the bottom. Now these are used for ACE. So whenever we create a marker in ACE, like say that underlines, for example, a piece of text, then we get an identifier back, and we need to keep those identifiers so that we can then later remove them when we want to sort of update the markers. Cool. All right. And so there's a bunch of toggling functions there. It's pretty straightforward. And so what we see here, this compile clicked function, this is where it's like the start point for compilation. So the user has pressed the compile button. This compile clicked function is going to be called from the button. It is accepting a mouse event, which we don't really need in this case, and a state, and it's producing a state and some actions. And in this case, we're actually going to produce some actions. And the first thing it does is it moves us into the compiling state. And then that's basically it. And we're just going to return an action, and we can see the action here, and that's an IO query. And that's actually calling the getEditorText method, which is right at the bottom. And what that method is going to do is simply query the ACE editor and get the contents of the editor and return that. All right. And so if we have a look quickly at the getEditorText, there it is right down there at the bottom. So the getEditorText, so this is a method, which means in Whiley it's not a pure function, which means it can have side effects. So the methods are not executing inside the model, but they're executing outside in the impure space. But that gives us the advantage that we can actually do anything we want. So effectively, this is just normal JavaScript. And we're getting a window, and the first thing we're going to do is we're just going to look up the ACE editor, which happens to be called code in this case, and extract the editor session, which is this, and then we just get the value, and that's it. And then we're going to return that value, and that's going to take us back into the functional space. And the web.y framework kind of handles the gluing of those two things together. So let's go back up to the beginning. So this is where we were. And so the other aspect of our IO query is that we're passing in the continuation effectively. So this is where we want to go, the callback, where we want to go once the editor text has been retrieved. And what that's saying is we want to go into this compile begin function. And the compile begin function is down here. And this accepts a state, and it accepts the string that we got back from the IO query. And so that's the key. And so then this builds a compiler request, and the compiler request object, it basically contains the fields, that I've kind of decided in my protocol when communicating with the server. So for example, is verification enabled? What's the text we're going to compile? Do we want to produce counterexamples? And so on and so forth. And then we turn that into a string using JSON, the standard JavaScript stringify function. And then we're going to perform the actual post request in this case. And so that's going to post to the endpoint/compile. It's taking in my JSON, which is the JSON version of my request object, and it's taking in two functions, which are the two possible outcomes. One is a compile success and one is a compile error. Now, the first thing to note here is that compile error doesn't mean compilation produced a syntax error. It means that the request had some kind of network error. So the request can be successful, but the server found a syntax error or something like that during compilation. So if we look inside the compile success function, we see that it's taking the response, which is just a string back from the server, and then we're going to parse that into a compiler response. And actually, at this time, this is an unsafe operation, and I need to do some more work on actually figuring out how to safely transform from JSON strings into Whiley objects, basically. But that's to do in the future. And so we're going to check if the result is successful. And then I'm effectively a little bit more hackery here to work around a few sort of issues. But I'm just casting it into a compiler success object. And that just means it's got a few more fields, such as the JavaScript field and so on. And so basically, if the result was a success, then I'm going to go down this path. I'm going to set the model state to be success. I'm going to copy over the JavaScript that was returned. And then we're going to we're going to do actually two actions sequentially, so one after the other. The first one is just a call into a JavaScript function, which is called clear editor markers, and that's down below. I mean, it's written in Whiley, but it's just, sort of an arbitrary JavaScript function that can do whatever it wants. It'll take the window and it will go through and it will clear all the existing markers in the ACE editor. And likewise, I'm then going to call a timeout, and the timeout will call the callback method after 1 second, and that's going to call the ready run. And so what's basically happening is we move into the success state, and then after 1 second, we'll call this function ready run. And if we look down below, where is it? Ready run. That's going to move. There it is. It's going to move us into the ready run state. All right. And so then on the other side, it's basically a similar kind of situation. We had a compilation failure, so some kind of syntax error. So we're going to move into the error state. And so that just means that the red box will be visible. We're going to clear the markers again, as we did before. We're then going to set editor markers. So again, breaking out of the functional space to actually update the ACE editor. Again, it's all from within Whiley, but just out of the functional space. And that's going to return us, it's a query rather than just a call, because it's going to return us the list of marker IDs that we need to save so that we can clear them again in the future. And then finally, we just do the timeout and we'll move into the ready state. Notice that we move into the ready state when there's an error, a syntax error, because we haven't got any JavaScript, that we can execute. And so that's somehow key. Right, and that's pretty much it. Fairly straightforward, shows a whole bunch of different things going on, in particular access across the network and also access to the ACE editor. Great, that's all. Hope you enjoyed the demo.